Hello everyone, welcome to the class of Python programming. My name is Vivek. I am working as an assistant professor in the Department of Computer Science and Engineering, Mlritm, Dundigal. In today's class, we are going to learn about the basics of Python, what actually this Python is and how it has become a very fast emerging programming language nowadays. Okay, so Python can be considered as a blend of both programming as well as scripting languages. So if I want to iterate more, so a programming language is one which is compiled and run, whereas a scripting language used in internet purposes for scripting or website designing, etc. But Python can do both. It is having the capabilities of being an object-oriented programming as well as a scripting language. So let us go deep into the aspects of Python that makes it a wonderful conclusion for most of the real world problems. So in the brief description of Python, let us say Python is a widely used general purpose high level programming language. That is our Python, initially designed by Guido van Rossum in 1991 and developed by Python Software Foundation. It was mainly developed for emphasis on code readability, and its syntax allows programmers to accept concepts in fewer lines of code. So writing a program in Python is unlike to most programming languages like C, C++ or Java, where a certain syntax is followed. So if you look at a Python program, a common Python program, it just looks like you are writing a poem in English. Okay, it is that simple. It is just a flow of very readable instructions. Now, what is a Python's premise? Readability counts. What is that? This isn't just a review of syntax, it's an exploration of a philosophy. Python is designed to be clear, expressive, and even fun. We will journey from the simplest ideas to the most powerful features, understanding why Python is built in the way it is already there. Okay, so without considering for elaborate discussions and highly syntactic rules, it is an elegant way of putting our ideas if we are writing a Python program. Okay, so no declarations, just names. This is one of the important aspects. If you take the example of any programming language like C, C++ or Java, declaration of the variables was the most crucial one. When we are using a variable, we have to declare its type and make. Okay, for example, if you want to declare an integer in C or Java, the most common procedure followed will be int some x. Okay, this is how you declare in C, C++ or Java. So we have to tell the compiler that we are going to declare an integer. Okay, and that integer is named as x. Then we assign a value to the x. Now, what is the speciality of Python here? Okay, in Python, variables were not memory boxes. Okay, as the source states, what Python really does is make variables into names for the values. It is just names for the values. Okay, they do not correspond to fixed places in the memory. An assignment simply points a name to a data object. So that is the beauty of Python. Okay, so here if you are in C or C++ or Java, when you are creating a variable int x is equal to 10, that means you are creating an object with name x and size 10. Okay, sorry, the value 10. But whereas here in Python, if you are declaring some x is equal to 10, that means that x is going to point to a data object that holds the value of 10. Okay, so a variable's type is determined by the object it points to. That is called dynamic typing. So here we are not going to declare int x. Here we are going to declare some x is equal to 10. That's it. Okay, so see here, it is a data object of type integer and value 5. So you are assigning name x to that. Here float 7.3. This is an object. This is an object and this is an object. Okay, we are just assigning a name to that. Okay, a variable must appear on the left of an assignment before it appears on the right. Okay, so that is the only syntactic rule which we have to follow. So if we iterate on more on that, that means that so you have to give a value to that before you use it in the. So here we are assigning a value x is equal to 10. Then we can use something like this. Okay, so before using in the right hand side, we have to assign a value to the variable. If you take this example, x is names an integer object, x is equal to 5. Okay, then now x names a floating point value, the type changes to 7.3. Okay, so here a is equal to 5 given. This causes an error because x has not been assigned a value. This is an error because x is not assigned a value. Okay, so this is how the declarations works. They are not declarations, they are just the names. Means here we are reducing the overhead of writing a data type for every variable we are going to instantiate. Okay, so this part is done by the Python interpreter itself. So logic is defined by white spaces, not braces. So indentation, okay. If you heard the term indentation, which was not a mandatory thing in other programming languages, means it's a good programming practice. That's it. It's just a directive, not a rule. Okay. But whereas in Python, that is the rule. Okay, that is the rule because of using the indentation, we are just ignoring a lot of complex types like braces, etc., curly braces, etc. So we are reducing the size of the program. Okay, indentation is not optional styling. It is the syntax that defines the code blocks for control flow structures like if, else, and while loops, or even functions. Okay, if you want to declare something in a function, you use the declaration def and the function name, and you give the indentation. That means 5 white spaces, and you write whatever you want to write inside the function, and you just come back to the starting of the line, which means that it is going to tell the interpreter that the scope of the function is over. Okay, same applies with the control structures also. If you are using some if control structure, you write the statements that belong to if, then just go back to the leave the 5 spaces and go back, then it tells the interpreter that the if block is over. So instead of using an optional styling, we are making it mandatory, and we are removing the excessive programming like our curly braces, etc. Okay, so why shouldn't Python rely on the indentation and thereby save you the extra work of putting in the curly braces? So there are no curly braces in Python. Okay, that's going to save you a lot of lines in programming when you are writing extremely big programs. Okay, so let us see the examples of this indentation so that you can understand. So this is example 1 that is going to give you the correct indentation. So the last 2 print statements are the part of the if block. So here we are giving if age is less than 30. Okay, so print hello name, and if you can see, we are having 1 2 3 4 5 spaces we have left. That is our indentation. Okay, so 5 spaces, print hello, print I see you are less than 30, print you are so young. So these 3 statements are part and parcel of our if statement. Okay, so whenever you write a next line of program after the if block, you start from here. Okay, from here, so that the interpreter understands that you are going to exit the if control structure. So example 2, incorrect, different logic. Let us see what that is. So if age less than 30, print hello comma name. Only this structure belongs to the if. So it doesn't mean that it is going to give you error. Okay, it doesn't mean it is going to give you the error. So what happens for these 2 lines? These 2 lines are executed. That means you are getting these 2 print statements even though this condition is wrong. Okay, so irrespective of the outcome of the if statement, the program is going to print these 2 statements because they are not part of the if block, because the indentation is wrong. That means even if you give age 45, it is going to print I see you are less than 30 and you are showing, which is not going to satisfy our need. Okay, so whenever we are using the indentation is very, very, very crucial in Python. You have to first decide what is the scope of your either control structure or a function, and then you have to write the statements. A Python program is nothing but a amalgamation of all statements. Okay, now the anatomy of a Python program, how actually a Python program looks like. Okay, so for a Python program, that is the highest level program, is the highest level, which contains modules, The modules in turn contain statements which are also known as expressions, and these are statements are formed using something called objects. Okay, so objects are the basic building blocks of Python programming. Okay, so we are going to start learning Python using understanding more about these objects. Our journey starts here at the foundation. Objects are the stuff that our programs to do things with. Okay, so along with user defined objects, Python has a huge collection of inbuilt objects, which is going to make programming very, very easy. So let us dig deep into this and learn what these objects are. So Python's superpower, what made it more efficient than the existing other programming languages is it's the 4 foundational collections. So let us see what these 4 foundational collections are. Beyond single values, Python's true power lies in its built-in structures for handling collections of data. These are 4: list, tuple, dictionary, and set. So these things, list, tuple, dictionary, and set, are predefined in Python. That means we need not write a piece of code to define them. They are already defined. Okay. So what is a list? Ordered and mutable. Okay. Ordered means it is in a order, one by one. Okay. Next, mutable means we can change at any point of time. Okay. That's not fixed. We can change at any point of time. That is your list. The versatile workhorse for sequence of data. That is your list, and it is represented using the square brackets. Square brackets is your list. Okay. Next one are the tuples. So what are these tuples? Ordered and immutable. Again, they are ordered, they appear one by one. Next, immutable. Immutable means you cannot change any tuple once it is defined. Through the end of the line, they are going to stay the same. Okay. For fixed data that should not change, we are going to use a tuple, and it is represented using our brackets. Okay. So this gives your angular brackets, we call them, or simple brackets, that is your tuples. Next, we have a dictionary. In general sense, what is a dictionary? That contains meanings of the words, and if you open a physical dictionary, you will find something called an index that is going to show which alphabet the word belongs to, and there you are going to search for the object. Okay, so the typical working style of the dictionary is brought back into this inbuilt object. So what does we have in our dictionary? Here we are having key value pairs. Okay, for fast lookups based on a unique key. That means we are using to store data using keys. So if you want to go for an object, you just find out on what key it is operating, and based on that key you are going to find out the object. So key value pairs, that is your dictionary. Set, this I think you are familiar in the basic mathematics you have learnt in computer sciences, that is mathematical foundations of computer sciences. There you are having sets, ordered and unordered and unique. For membership testing and mathematical set operations, like you are having something like this: A union B. That means all the elements of A and all the elements of B. A intersection B. Elements present in both A and B. A equal to B. A not equal to B. So sir, that we are having different set operations for our mathematical applications. So in this class, after this, we are going to learn in detail about these 4 basic built-in data structures of our Python programming language. Okay. Now, why these built-in types are your superpower? So what makes them very prestigious? Let us see. The first one, they accelerate the development. That means it is going to speed up the development. Built-in objects make programs easy to write. Powerful tools like lists and dictionaries are available immediately, letting you to solve the problems faster. That means we need not write a program to give a shape to that. Okay, so if you want to store data in a particular format, where you have to define them first in other programming languages. First you have to define the data structure, then you have to enter the elements, then you have to make the operations, and then you have to exit. Whereas in Python, what it is doing, having built-in tools like your lists and dictionaries and tuples, etc., you are going to have the template ready. Okay, you can just insert the values and you can operate them. No need to define them. So that is going to accelerate the development. Programming becomes more faster and more agile. Next, provide strong foundations. They are the components of extensions. Even complex custom objects are often built on top of core types like dictionary, list and dictionary. So based on our requirement, if you want the values to not to change at any point of time, you use a tuple. If you want to change according to your need, then you use a list. In that way, you can select different things at different levels of programming and they can build upon these core objects. So that is where they are going to provide the strong foundations. That means a list is unique, a tuple is unique, a dictionary is unique, and sets are unique. They are having their own plus and minuses. So based on our requirement, we are going to select them. Okay. Next, we have the optimized for performance. Obviously, why do we arrange something predefined? Okay. So why do we have some things that are already prepared? That is for optimization of performance. Okay. These are highly efficient. Python's built-ins use optimized data structure algorithms implemented in C for speed. Obviously, C is the most fastly executed language, C compiler. So these are built-ins are developed in C so that they are very optimized for performance. Okay. Next one, ensure standardization. They are standard part of the language. This guarantees consistency unlike proprietary frameworks that differ from side to side. So these can be used in every machine that Python works on. Okay, it is not dependent on hardware or software. Okay, they completely belong to the Python programming language. So they are not any customized things. They are the predefined things. So these four qualities makes those four fundamental data objects as the superpowers. Okay, in typical Python programs, most of this grunt works goes away. So no need to declare a variable, no need to declare a list, no need to declare a tuple, no need to declare a dictionary. You can directly insert the values into them and you can use them. Okay. Now, so the landscape of core data types. What are the core data types that a Python interpreter is going to handle? Okay. So let us see what they are. The first one is numbers, strings, lists, dictionaries, tuples, files and sets. So these are your core data types. Everything we process in a Python program is a kind of object. All these are by default objects. They form the foundations of our Python programming. There are the core tools. These are the core tools, each with its own specific syntax and purpose. So they are having their own syntax as well as they have their own purpose. They are unique in every way. Okay. So for now, let us learn about the first core type, that is our numbers. Obviously, programming language are mostly used for mathematical calculations. So let us see what these numbers and how they are represented and how it is different from the other existing programming languages. So first stop, the world of numbers. Okay. So Python's numbers are the bedrock of computation. These are not a single type but a category of similar types, from simple integers to more exotic tools for high precision work. Okay, so simple addition of two numbers to we can make most sophisticated and high-end calculations. Everything is present in the Python programming language. Okay, so the first and the most important one is the integers, which are very widely used. Then these are the whole numbers again. Okay, I think you people understand the difference between a whole number and a decimal point number, right? So there are no decimals, then we call that as a whole number. So floating point deals with the decisions. Complex, it contains both numerics and characters. Next, hexa, octal and binary. With the base, we are going to calculate those numbers. And the specialized types called decimal and fraction. So these are the different types of numbers present in Python. Okay, we can directly use them and let us see how each of them work. Okay, now the language of numbers is the operators and their precedence. What are the operators and how they are going to work? Okay, so the common operators we are having are plus, minus, multiplication, power. So this A double star B represents A to the power of B. True division, that is a singular division object, and floor division, that is going to round up the quotient, and here percentile, reminder, that gives you the remainder, modulo. Okay, so the rules of the combination are: precedence operator with higher precedence like multiplication and division are evaluated before those with the lower precedence like plus and minus. So 2 plus 3 into 4, in this first 3 into 4 is calculated first. So that gives 2 plus 12, which is equal to 14. So it is not a conventional sequential or linear type of execution will take place. If that is the case, then it becomes 2 plus 3, 5 into 4, 20, which is the wrong answer. So what is the output of this? First, we are going to look for the precedence. Then we are going to do. And next one is a parenthesis. Obviously, you can always override precedence rules by grouping the expression with the parenthesis. So whenever you have a parenthesis, that is going to nullify all the arithmetic operators. That has to be executed first. Okay, even though plus has of lower precedence than multiplication, but these two variables are bound in a parenthesis. So this is executed first. So 5 into 4, which is 20. Okay, so that you can use parenthesis to override the precedence. Next, mixed types. Python converts operands up of the type to the most complex operand. So when you are using more than one type of operands, then it is going to convert to the highest precedence value. For example, 40 plus 3.14. Here, automatically interpreter takes 40 as an integer and 3.14 as float. So whenever you are using an operator to convert, what happens? The interpreter directly converts the lower data type, which is an integer, to a higher data type, which is a float. So that becomes 40.0 plus 3.14, that is equal to 43.14. So that is how we work with the numbers in Python. So a tale of two divisions. This is actually present in the before versions of Python. From Python 3, there are no floor divisions. The floor is automatically calculated. For example, you can see here in Python 2, it is a classical division and it is a true division. It truncates for integers but keeps both the remainders for floats. So when you are using a single division operator before 3, means up to 2.7, 2.8, what was the function? In 2.6, it was 10 by 4 gives you result 2. But actually, what is the result? It is 2.5, right? So it is rounded to 2. Whereas for float 10 by 4.0, it is going to give you the 2.5 because it is a float division keeps the remainder. Okay, so behavior depends on the types of the numbers. But what happened from after Python 3, 3.1, 3.2 up to 3.14, which is recently released, we are having it is a true division. That means in Python 3.0, 10 by 4 gives you 2.5 and 10 by 4.0 also gives you 2.5. That means consistent and predictable behavior. Okay, so it again, what it is doing here, 10 is a whole number which is an integer and 4 is also a whole number which is an integer. So when you are performing an operation, the result is coming in the form of float. So what interpreter doing here after 3.0, it is converting into the required thing. Okay, not the original thing. Whatever be the variables originally they are, it is not going to go for them. It is going to convert to what actually is required. No truncate functions or roundup functions are performed. Whatever be the result, as it is displayed. That helps in the transparency of programming. Okay, so we don't need to again convert it into float so that we can get a real answer. Okay, we are going to get a real answer after 3.0. Okay, 3.1, 3.2, 3.3, any version you are going to take, you are going to get the actual result. Okay, now the universal constant is float division. Again, you can use, okay, it always truncates the fractional remainder in both Python 2.3. It doesn't mean that you cannot use double float division in Python 3. You can still use that. Okay, sometimes you want result truncated. Then what is the use of using a single one? We are going to use the double one. So you are going to get the result 4. Again, in 3.0 also, after third version also, you can use double for truncated floor division. Okay, for predictable truncating integer division that works in all Python versions, we use double division. So here, one of the important other concepts you have to know about Python numbers are integers are without limits. So previously in other programming language and also the previous versions of Python, there are different levels of integers. We have for small numbers, we have int. For long, we have long, double, etc., etc. Okay, so here that is not the case. There is nothing called long or anything. In Python 2.6, we have int normal and int long, which is unlimited. Python automatically converts long when a number is got too large. You will see it marked with a trailing L. That is not the case with Python 3. Here, whatever it is, the size of the integer is how much your machine supports. That is completely depends on that. If your machine is going to support a very large number, then that very large number is again considered as an integer. No other type is required. There is only one integer type int which has unlimited precision. Okay, Python's integers can be as large as your machine's memory allows. You are using a simple calculator, it allows only 16 digits. Okay, if you are using a computer, it might allow more than 16 digits. If you are using a supercomputer, it might allow even more digits. So that completely depends on the hardware of the machine which you are using. Python is unlimited numbers. Okay, it is unlimited and highly precise in Python. Okay, so here for example, you can say 2 power of 100 we have taken. 2 double star 100 means 2 power of 100. This is the output, which is again always a integer. If your computer is going to support that, it is memory dependent. If it is going to support, it is going to show you all these things. Okay, now how many digits are there in 2 power there? So length of string of 2 into 2 power some, we are going to get the length. So that is 3,01,030 digits are also we can see. Okay, so here why we are using this string, we will learn when we are going to deal with strings. Next, we have the field nodes, which are hex, octal and binary notation. As you all know, hexadecimal base 16, octal base 8 and binary is base 2. Okay, those are represented using these things. Okay, Python 2.6 also orders out of 0377 syntax for older, but from the O form is preferred and is mandatory in Python 3. So Python 3 is a very modified and sophisticated, which is going to remove all the problems that we have with the Python in the previous versions. Here it starts with 0x or capital X, small x or capital X. Everything we have in the hexadecimal. In the octal starts with small o or 0 and o. That is your octal. 0 o 377. We are getting the value of 255. Binary again 0b or 0 capital B. That is your binary representation. Okay, so conversion tools use built-in functions. You can use built-in functions like hex, oct and binary to directly convert them into those forms. So if you want a hexadecimal from an integer, you can directly use the function called hex. Octal you can use OCT, binary you can use bin and the number, and you are going to get your values. Again, there is no need of writing a program. They are predefined functions in Python. Okay, so string to integer. So using the int function with a base, you can convert everything into these things. Okay, ff is converted to 255, 1010 is converted into 10 because of it is base 2. So these things, you can int function is used with a base to convert into whatever. We can convert into octal, hexadecimal or binary. These are the built-in functions in Python. So we have some extended numeric toolkit also to make some functions and make Python very good option for doing mathematical calculations. For example, the math module. So module is one of the important concept, which is an extension of the like packages in Java. We are having modules in Python, and each module, and Python is very rich in modules. They are going to have module for almost every type of calculations you require. So by implementing the math module, so how you are implementing, you are going to just import math. So that is a predefined module. We are going to import math and we are going to get math.py, math.square root and math.py by 2. You are going to get the values. Okay, so math of sine value also you are going to get. So next one, we are having the random manuals for simulations, games and statistical sampling. So this is also one of the important thing. What is random? That means not an order. We are not going to follow an order. So for game development, online game development, Python is the very useful tool to design. So random, a random float between 0.0 and 1.0. Random rand int 1, 10, a random integer between 1 and 10. Random.choice 1, 2, 3, a random item for a from a sequence. This you can get with your random module. All you have to do is import random. Okay. So next, built-in functions always available. No import needed are these functions. POW. It will gives you to the 2 to the power of 4. That is 2 into 2 into 2 into 2. That is 2 to the 4, 4 to the 8, 8 to the 16. That is your answer. Power of you are going to get. Absolute. You are going to get the negation. You are going to get the output. Round. We are rounding to 2 digits. So 5.67 gives you 57. 2.57. So sum of 1, 2, 3, 4. You are going to get 10. Minimum of 1, 2, 3 is 1. Maximum of 1, 2, 3 is 3. So these are the answers you are going to get. So these are the built-in functions that doesn't require to import anything. Okay. To get the power of a number, no need of importing math or random or any other. These are the built-in functions readily available in the core Python library. Okay. So this is the extended numeric toolkits. Okay. So again, we are having some high precision instruments like decimal and fraction. Let us see what's the use of that. Okay. Standard floats are fast but can have small precision errors due to their binary representations. Okay, so these might have problems. For example, if you can see 0.1 plus 0.1 plus 0.1 minus 0.3. Okay, if you can calculate this, 0.1, 0.1, 0.1 becomes 0.3 and minus 0.3, expected output is 0, 0. But what you will be getting actual output, that will be something like this. Why? Because these numbers are treated as binary. Okay, so how can we avoid that? That can be avoided using the decimal type and the fraction type. So how it is done, let us see. The decimal type, a fixed precision floating point number, ideal for financial applications where precision is fixed. For example, 2 decimal places for currency. If you want to convert it into 2 decimal places, you can use decimal. And fraction, a rational number that explicitly stores a numerator and denominator. It avoids floating point issues entirely by representing values as exact ratios. So these are the two things, decimal type and fraction type. So how we are going to get these things? From decimal, import decimal. Okay. So from fractions, import fraction. So these are the two statements you are going to get the high precision instruments in Python programming. If you can see here, decimal of 0.1, decimal of 0.1, decimal of 0.1. These are converted into these things. Okay. So these are converted into decimal here and these are converted into fraction. So we are going to get fraction of 0, 1. Here we are going to get decimal 0, 0. Okay. So this is how it is actually going to work. So next we have the comparison operators. So what is happening with this comparison? Programs make decision by comparing values. The result is always Boolean, which is true and false. So here key comparison operators, we are having the greater than, less than, greater than or equal to and not equal to. So what is true? 18 is a bit heavier than 16, which is true. That is represented by the diagram. The most important distinction you have to always follow, same like other programming languages, is single equal to is an assignment, whereas double equal to is a comparison. Okay, single equal to is an assignment. We are giving a name to a object, where double equal to is comparison. We are going to compare the two values. Okay. So what are the important laws of the land? Core Python concepts. What are they? On which Python is built? Okay. So let us see this core Python concepts. The first one is the polymorphism. Okay. The meaning of an operator depends on the objects being operated on. This makes code flexible and reuse. For example, if you are using with integers, plus stands for addition of values. Whereas if you are using plus with strings, that stands for concatenation. That means, and again, I'm reminding you, we are not going to define the data type in Python while we are declaring. So it is up to the interpreter to define the data type. So here, when we are using an operator also, that is the interpreter that is going to decide what to do with the operator. That means if you are giving integers and giving a plus operator, the interpreter decides that they are strings and they have to be added. And if you are giving strings and using the plus operator, the interpreter decides that these are the strings and we have to concatenate them. So 1 plus 2 gives you 3, which is addition, and a plus b gives you ab, which is concatenation. Okay, so that is your polymorphism that is being exhibited by the Python programming language interpreter. Okay, second one is immutability. So what is this immutability? Immutable objects cannot be changed in place after creation. Numbers, strings, and tuples are immutable. Okay, so these are the immutable things. What are those? Numbers, strings, and tuples are immutable in Python. For example, s is equal to spam, you are having s of 0 is equal to z, you are telling. Not possible. You can't just take out yes and put z there, because s is a string and string is immutable. Once defined, it is defined. You are not going to change that. You cannot change that. So how can you change that? By just creating a new object. What is that new object? We are assigning s some other value. What is that? Z of s of 1 plus. So this is called slicing, which we will be learning when we are learning about strings. Okay. Next, strong and dynamic typing. Okay, so here z plus s of 1 becomes s of 0 value, it will be z, and s of 1 to end of the string. So that means we are going to get p, a, and m. S is omitted here because we are taking it from 1. Okay, so that becomes this output. Okay, this one. Now, strong and dynamic typing. So here Python knows an object's type which is dynamic, but it won't let you perform invalid operations on it. So you can see that Python interpreter is deciding what kind of variable you are declaring, and what kind of operator you are declaring. Okay, so you can test the interpreter. Okay, how can you test? Let us see here. Python won't magically convert a string to number. 1 plus spam. This is not possible because 1 it is considering as an integer and spam is a string. You cannot perform operations on two types of objects. Okay, so that we are going to get the type error. So here both it is dynamic typing. That means dynamically interpreter decides what kind of data object you are using, and again it is strong because you cannot do malpractices there. You cannot do unwanted or avoidable functions. So this is the basic core type numbers in Python. In the next class, we are going to learn about more classes of inbuilt types of Python. Okay, thank you for the day.